Okay, today we're going to learn about chapter 3, system of equations. Okay, the first one is 3.1, that is equation of three variables. But before that, let's do a revision on system of equation with two variables. Alright, so I gave you two examples here. The first example, 2x plus 3y equals 6 and x plus 2y equals to 5. So how to solve this simultaneous linear equation? Okay, you have two choices. One is substitution, the other one is elimination method. So I'm going to show you elimination method. So in this case, I'm going to eliminate x variables because y variables is a bit hard. It involves 3 and 2, the coefficient for y. So you want to eliminate y, that means we have to multiply 2 here for equation number 1 and 3 equation number 2. So it's a bit troublesome. So let's get rid of the x. Just before that, we have to multiply 2 for this equation number 2. So we'll get 2x and 4y equals to 10. Why we have to multiply 2 here? Okay, so in order for us to eliminate x, we must make sure the coefficient for x is the same, right? So in this case, is the coefficient of x is already equal, right? Then we have to look at the symbol. So these two are positive, therefore we minus. If this is positive, this is negative, then we plus, right? So we minus. So when you minus 2x plus 3y equals 6 minus 2x minus 4y equals 10, so 2x minus 2x equals to 0, 3y minus 4y equals to negative y, and then 6 minus 10 equals to negative 4. Therefore, we have y equals to 4, right? Then you can get the value of x by substituting the y equal to 4 into the equation number 2, right? Equation number 2 is x plus 2y equals to 5, right? So when you substitute in, you get x plus 2 times 4 equals to 5. You get x plus 8 equals to 5, and hence you get x equal to negative 3, right? So this is example 1. So let's see the example 2. Example 2, we have x plus y equal to 2 and x minus y equals to 4. So in this case, we no need to multiply any numbers here or constant here because both x and both y has the same coefficient. So for example 1, I already eliminate x, right? So now I'm going to eliminate y, right? So to eliminate y, you see the symbol first. Coefficient we know already is 1 and 1. So the symbol positive and negative. So it's opposite or different symbol. Therefore, we add these two equations together, right? Like this. So you'll get x plus x equal to 2x and y plus minus y will be y minus y equal to 0, and then 2 plus 4 equals to 6. So you'll get 2x equal to 6, x equal to 3. And same goes for equation for example 1, right? So we'll substitute x equal to 3 into equation number 1 or equation number 2, right? So I will choose equation number 1. So your x plus y equal to 2. So 3 become 3 plus y equal to 2. 2y, right? 3, you move it to the right hand side. 2 minus 3, you get negative 1. So our answer for this equation, this simultaneous linear equation will be x equal to 3, y equals to negative 1. All right? Okay, let's see how to describe a linear equation in three variables. Okay, so the general form of linear equation in three variables can be written as ax plus by plus cz equals 0, where a, b, and c are not equal to 0. Okay, let's refresh back for system linear equation with two variables. Alright, so from the previous examples, we have 2x plus 3y equals 6, x plus 2y equals 5. Okay, there is a pair of equation here. Right, same goes to the x plus y equal to 2 and x minus y equal to 4. Also a pair here. But for system linear equation with three variables, we have three linear equation. For example, like this: x plus 4y plus 3z equal to 2, 3x minus 3y minus 2z equal to 4, x minus y minus z equals to 4. Okay, this is only an example. Alright, so how you describe a system of linear equation with three variables with ax plus by plus cz equal to 0. Right? The second part is the system linear of equation in three variables has three axes, namely x-axis, y-axis, and z-axis. Okay, this is graph. How to represent in the graph form. All three linear equations form a plane on each axis. Okay, so this linear equation will form a plane. Then every linear equation in two variable forms a straight line on each axis. Okay, meaning that x plus 4y equal to 2 will form a straight line, 4y plus 3z will form a straight line, and then x plus 3z will form a straight line. So there are three straight lines. You combine it, it will become a plane. Alright, later on we will see how to sketch the graph. Okay, now we want to sketch linear equation with three variables, but before that let's do revise on how to sketch linear equation with two variables. Okay, so for example, we have x plus y equals to 2, right? So what we need to do is to find the y-intercept, the x-intercept. So in order to find x-intercept, let y equal to 0. So when y equal to 0, x equal to 2, right? So very clear, right? So if I cover up like this, that means x equal to 2. When I want to find y-intercept, then x equals to 0. So you have x equal to 0, y equals to 2. Therefore, we start to sketch the graph. Draw a two straight line. Okay, arrow going here is x-intercept, horizontal is x-intercept, then vertical is y-intercept, and this is 0, the origin. So this part will be positive, and then this part also positive. So we have y equal to 2 and x equal to 2. So we put 2, let's say this is 2 and this is 2. And then you just join the 2 points together. Voila, this is your graph for x plus y equals to 2. Now let's see how to sketch linear equation with three variables. Alright, so for example, I have graphing a linear equation in three variables. The example is 3x plus 2y plus 4z equal to 12. Same goes with the equation with two variables. We find all the intercepts first. That means x-intercept, y-intercept, and z-intercept. Right? So for three variables, if I want to find z-intercept, I have to let x and y become 0. Okay, let's say x equal to 0, y equals 0. That means I cover up these two, then y 4z equals to 12, right? And then z will be 3. 4 times 3 is 12, right? So z is 3. Then I can go to find x-intercept. So x-intercept, I have to cover up y and z. Okay, y and z. I cover up these two, z, this one and this one. Then you can get 3x equals to 12. So you get x equals to 4. And then I want to find y-intercept. I cover up the x and the z. So I get 2y equals to 12. Then you have y equal to 6. So you get x-intercept, 4, y-intercept, 6. Now we can sketch the graph for the equation of three variables is a bit different from linear equation with two variables because we have three axes. Okay, so how we sketch, it's like this. So this is y-intercept, z-intercept, x-intercept. So I need to explain here. So for y-axis, the right side is positive. This part is positive. For z-intercept, z-axis, the upper part will be positive. But for the x-axis here, okay, this part will be positive and this part is negative, right? So after you have sketched the axes, then we can plot the points. The first point is z equals to 3, right? So z equals to 3, so we estimate here is 3, right? Okay, and then y is 6, y-intercept is 6 here, and then x-intercept is 4 here, right? So remember, this part x is positive. Okay, maybe some of you will be confused, why not this part, right? If you turn up here, become x-intercept, this one x-intercept, this one z-intercept, then you can see here clearly the upper part is positive, right? So, and then after you plot the three intercept, then you join up together with a straight line. 3 to 6, 6 to 4, and 4 to 3, we'll get a plane, right? So you join up, you get a plane like this. So this is how you sketch linear equation in three variables. All right. Okay, so now we're going to see how many solutions are there for system of three linear equations, right? So there are three types of solutions. Okay, for you can see here for these examples. Okay, so x plus 2y minus 3z. Okay, x plus 2y minus 3z equal to negative 3, and 2x minus 5y plus 4z equal to 13, and 5x plus 4y minus z equals to 5. If you solve it, you'll get a solution like this, x, y, and z, right? So the solution is 2, negative 1, and 1. So this system above has only one solution. Right, doesn't mean that all system of three linear equation will have one solution. Okay, let's look at others. Okay, the graph of a linear equation in three variable is a plane in three-dimensional space. The graph of the three such equations that form a system are three planes whose intersection determines the number of solutions of the system, as shown in the diagram below. So if only one solution, you'll see clearly here, the three planes here, the red plane, the green planes, and the blue planes will intersect at one point. Okay, exactly one solution. Alright, then the second diagram will show you the planes that intersect in a line or are the same plane. You can see here the blue planes, the green and the red planes intersect at one straight line. Okay, and this one will be infinite many solution. That means the solution, there is a lot of points here. Okay, you can see here there's in this diagram is only shown to you is a small part of it. So it can be extended into up and down, right? This part. Okay, so these are the two solutions. There's another solution. Okay, another solution is this. This has no solution at all. Okay, you can see here the first diagram here. Okay, the blue and green only intersect at a line. Red and green also intersect at a line. And red and blue intersect at a line. But the three lines are not intersecting each other. So therefore, there is no solution, meaning that there is no intersection between the three planes. Okay, the second diagram you can see here quite clear also. The red planes intersect the green and blue at two lines, okay, but not a point. And then the third one will be the three planes are not intersecting each other, they are parallel. So here is very clear that there is no solution or no intersection between the three planes of the three equations. All right. Okay, I'm going to show you how to solve simultaneous linear equation with three variables by using substitution method and elimination method. Right. So I choose z as to substitute z variables. So z will be our subject. From equation number 1, you'll get z equal to negative 4x plus 3y minus 10. Okay, so you can see equation number 1, you move 4x minus 3y to the right hand side, you'll get negative 4x plus 3y minus 10. Okay, then we substitute 4 into 2. Right, so we'll get 2x plus y times plus 3 times negative 4x plus 3y minus 10 equals 0. That means our z now is negative 4x plus 3y minus 10. Then you expand it, 2x plus y equal to negative 12x plus 9y minus 30 equals 0. And then you collect the same term together. That means 2x minus 12x plus y plus 9y minus 30 equals 0. You simplify, you'll get negative 10x plus 10y equals to 30. Then we simplify by dividing with 10. Then you get negative x plus y equals to 3. Hence, we'll get y equals to 3 plus x or x plus 3. Then the next step, we'll substitute equation number 4 and equation number 5 into equation number 3. Okay, you can see here negative x plus 2 times x plus 3 minus 5 times negative 4x plus 3 times x plus 3 minus 10 equals to 17. Alright, so in equation number 3, you notice that the y, 2y will become 2x plus 3, and then 5z will become 5 times minus 4x plus 3y minus 10. And then the y will be substituted by x plus 3. Therefore, you get this equation. Right? And then you go and expand it. Alright, you get negative x plus 2x plus 6 minus 5 times negative 4x plus 3x minus 1. Okay, minus 1 is from 9 minus 10. So equal to 17, and then you simplify the bracket. You get negative x minus 1. Alright, and then you expand the bracket, you get negative x plus 2x plus 6 plus 5x plus 5 equal to 17. Alright, and then you do the computation. At the end, you get x equal to 1. Then you substitute x equal to 1 into the equation number 5. Okay, so equation number 6, substitute into the equation number 5, you get y equals to 1 plus 3. Okay, and then y equals to 4. Then y equals to 4 and x equals to 1. That is equation 6 and 7. You substitute into equation number 4. You get z equals to negative 4 times 1 plus 3 times 4 minus 10. Therefore, z equals to negative 2. Okay, so that is substitution method. Now we are looking at elimination method. So elimination method, you're going to eliminate one of the variables. So I'm going to eliminate the z variable. Okay, so I have to multiply equation number 1 with 3. So you get 12x minus 9y plus 3z equals to negative 30. Okay, so why I do like that is that I want to eliminate z from equation 1 and 2. Equation 1 and 2, you can notice that the z and 3, the z, one is coefficient is 1, the other coefficient is 3 for equation number 2. So it's not equal. So when you want to eliminate using elimination method, you must make sure the z variables has the same coefficient. Therefore, you times 3 to 1. Right? So you get the equation number 4. Then you bring down equation number 2 from the original equation. Okay, and then you can minus the 2 equation, that is 4 minus 2. So you get 12x minus 2x, you get 10x, and then negative 9y minus y, you get 10y, negative 10y, and then negative 30 minus 0, you get negative 30. So as usual, you divide by 10, you'll get equation number 5, that is x minus y equals to negative 3. Okay, now the second step, you're going to get another linear equation. Now we are going to minus or plus equation 1 and 3. So you notice 1 and 3, the set variable 1 has coefficient 1, the other coefficient is negative 5. So you have to multiply equation 1 with 5. So you get 20x minus 15y plus 5x equals to negative 15. You get equation number 6. Then you rewrite equation number 3 after it. Then you get negative x plus 2y minus 5z equals to 17. Then you will do plus. The process is plus because the variable for z, one is positive 5, the other one is negative 5. So you add it together to eliminate the z variable. So eliminate 6 plus 3, you eliminate the z, you get 19x minus 13y equals to negative 33. Then we need to eliminate again one of the variables, okay, from 5 and 7. So 5 and 7, you'll notice that for x and y, the coefficients are not equal. So I want to eliminate the x variable from 5 and 7. Therefore, I have to multiply equation number 5 with 19. So you'll get this. 19x minus 19y equals to negative 57. Then now 7 and 8, I can minus it, right? So from 8 minus 7. So you get negative 6y equals to negative 24. Therefore, y equals to 4. Okay, then I substitute back y equal to 4 to equation number 5. So you get negative x will become 1. Then substitute x equal to 1 and y equal to 4 to equation number 1. The original equation 1, you get 4 times 1 times minus 3 times 4 plus z equals to negative 10 and z equals to negative 2. So by using elimination method or substitution, you should get the same answer for x and y and z. That is x equal to 1, y equal to 4, and z equals to negative 2. Okay, now we're going to solve example B. Okay, so I'm going to use substitution method. Right, so it's very clear from 3, we'll get y equals to 5z minus 3. So you can see in this example, equation 3 has no x variable. Okay, so this is also system of equation with three variables, although one of the variables is not there or the coefficient is 0. Okay, so from 3 you get y equal to 5z minus 3. You form equation number 4. Then from substitute number 4 into number 1, so you'll get x minus 5z minus 3 plus 3z equals to 3, meaning that the y now in equation number 1 will become 5z minus 3. So you expand it, you get minus 5z, x minus 5z plus 3 plus 3z equals to 3. Hence, we'll get x equals to 2z, right? Because minus 5z plus 3z equal to minus 2z, you bring to the right hand side, become 2z, and then 3 you bring to the right hand side, become minus 3. So 3 minus 3 equals to 0. Then the next step will be substituting 4 and 5 into equation number 2. Okay, so you can notice that we already used out equation 3 and 1, so meaning that the next one will be equation number 2. So you substitute into number 2. Remember, you cannot repeat to substitute into 1 again, right? So you must use all the 3 equations. So when you substitute 4 and 5 into 2, meaning that whatever inside equation number 2 is x and y will become variable z. Okay, let's see it. So negative 2 times x become negative 2 times 2z, and then plus 2y will become plus 2 times 5z minus 3, and then minus 6z equals to 6. So you expand it, you get negative 4z plus 10z minus 6z equals to 6. And then you do some computation, you get negative 4z plus 10z minus 6z equals to 12. Then negative 4z plus 6z plus 10z, you get 0 equals to 12. So hence this system of linear equation has no solution because 0 cannot be 12. So in this case, example B has no solution because what we get is 0 cannot become 12. Alright, so now we're going to solve example C. Okay, so I'm going to eliminate z's variable from equation 1 and 2. Okay, later on we'll do eliminate z variable from 1 and 3. So to eliminate z variable from 1 and 2, that means equation 1 I have to multiply by 2. Okay, so I will get 6x plus 10y minus 4z equals 26. So now I drag equation 2 down like this. Okay, so you can notice it very well that negative 4 is the coefficient for variable z in equation 4 and 2. Therefore, I have to minus the 2 equation. So I minus 4, use 4 minus 2. So you get 6x minus 5x, you get 11x. And then 10y minus 2y, you get 12y. And then negative 4z minus 4z, you get 0. And 26 minus 20, you get 6. Right? So this is equation number 6. Then I will eliminate z from equation 1 and 3. Right? So equation 1 and 3, you will notice that negative 2 is the coefficient for z in equation 1 and 2 is the coefficient for z in equation number 3. Alright, so we can add these two equations together to get rid of z because the signage is different, right? Okay, it's the opposite signage. So you get negative 3x plus 5y minus 2z equals 13, negative 14x minus 17y plus 2z equals to 19. So you add this together, these two equations together, you get 3x minus 14x, you get negative 11x, and then 5y minus 17y, you get negative 12y, and then 13 minus 19, you get minus 6. Okay, so you get equation number 5. Then you eliminate x or y from equation 5 and 6. So I eliminate x from 5 and 6. So you can see the coefficient is the same, but the signage is different. So I add 5 and 6 together. You will notice that you get 0 equals to 0 because 6 minus 6 equals 0, 12 minus 12y equals 0, and 11x minus 11x also 0. So you get the result 0 equals to 0. So what is the conclusion then? The conclusion is the system of linear equation. This system of linear equation, example C, has infinite solution because 0 equals to 0. So you can notice that B and C, the difference is one is 0 equals to 12, the other one is equals to 0. 0 equals to 0, right? So if 0 equals 0, then it has infinite solution. If 0 equals to some constant, therefore there is no solution. Okay, so this is the example for C. Okay, problem solving. Right, so problem solving. So we read the question first. Patricia invested Rm 24,500 in 3 unit trusts. She divided the money into 3 different unit trust accounts P, Q, and R. At the end of the year, she obtained a profit of 1,300. The annual dividends for the account are 4%, 5.5%, and 6% respectively. The final amount of money in account P is 4 times that in account Q. How much money did she invest in each unit trust account? So we start off with the first question, right? So let X be the amount of money of P, Y the amount of money of Q, and Z is the amount of money of R. Alright, so from here you can see here she divided the money into 3 different unit trust account P, Q, and R, right? And then she invested 24,500. So altogether she invested 24,500. So we have X plus Y plus Z equals to 24,500. Okay, so this is our equation number 1. For our equation number 2 is from the third sentence. So at the end of the year, she obtained a profit of 1,300, and the annual profit, if the dividend is 4%, 5.5%, and 6% respectively. So 4% is 4 over 100, and then 5.5% is 5.5 over 100, and 6% is 6 over 100. Okay, so we have this equation: 4 over 100 times x, 5.5 over 100 times y, and 6 over 100 times z equals to 1,300. So this equation we multiply by 100 to get rid of the denominator 100. So you get 4x plus 5.5y plus 6z equals to 130,000, right? 130,000. Then the last equation is from the final amount of money in account P is 4 times that in account Q. So we'll get x equals to 4y. Okay, this is our third equation. Okay, let's solve this equation. Okay, so for this case, it's easier for us to use substitution method since we have x equal to 4y. So we substitute 3 into 1. Okay, 3 into 1 to get rid of the x. Okay, so you have 5y plus z equals to 24,500. Okay, how to get 5y? With 4y, you substitute in 1, then 4y plus y is 4y, become 5y, and plus z equals to 24,500. Therefore, our z equals to 24,500 minus 5y is our equation number 4. Then we substitute 3 and 4 into equation number 2, right? Okay, equation number 2. So 4x will be 4 times 4y, and then 5.5y plus 6z. Z will be 6 times 24,500 minus 5y. So you get this equation. Alright, and then you expand it. You get 16y plus 5.5y minus 30y plus 14,700, okay, equals to 130,000. Okay, so this one we already rearrange. Okay, and then you simplify this part, you get what? Negative 8.5y equals to negative 17,000. Okay, 147,000. You move to the right hand side, become 130,000 minus 147,000. 147,000, right? So you get this negative 17,000. Then you divide both sides with negative 8.5. You get y equals to 2,000. Then from here, you can substitute y equal to 2,000 into equation number 3. So you get 4 times 2,000, you get 8,000 for x. And then for z, it will be 24,500 minus 5 times 2,000 is 10,000. You get 14,500. Therefore, the amount of money in PQR are RM 8,000, RM 2,000, and RM 14,500 respectively.